So we should do Planck's length. Okay, let's do that. So we have to find, determine Planck length. Okay, let's do length. So as we did in class, what's the first thing we need to figure out? Well, what do you think it depends on? It goes on the length. However, we did take the names of certain things. What did we say this was? Yes, but what's this word?
Light.
Good. So it has to do something with light. And it says the time required for light to travel. What do we call that in physics? The time to travel a certain distance.
The distance, change in time.
So good. Change in distance divided by change in time is called speed.
Yes.
So the one thing that it absolutely depends on is, because of our definition.
Are we talking about length right now or time?
No, we're talking about what Planck length depends on. So they're all related to each other,
Okay,
right?
I
So I'm just trying to figure out whatever I'm doing, whether it's Planck's time or mass or length, it doesn't matter. They all depend on the same thing,
Okay.
right? So they all depend on speed. Then the next thing that they depend on, what scale is it? What's Planck's scale? So it should have something to do with Planck's constant, right? Because that's the only way to get to the Planck scale. And that's where I was writing the E equals HF equation. Do you remember this? That's called the Planck's constant. So H is called the Planck's constant. The only thing that's kind of weird is that the other thing that it depends on is G. Does anybody remember what G is?
Gravity.
Nope, not gravity.
Gravitational
Constant. Why is that? Because this scale exists everywhere in the universe. The acceleration due to gravity, the small g, only exists on planet Earth, right? But do you remember where g came from? F equals g m1 m2 over r squared. Intro 1? Yes? That g exists everywhere in the universe. So if Planck's scale exists everywhere in the universe, it has to depend on g as well. And honestly, these are the only three things we need. The value of speed of light. Wait, what is it? Go one more.
I do that every time.
Planck's constant, 6.63 times 10 to the minus 34. Wrap your mind around that. It's 10 to the minus 34. Gravitational constant is actually 6.67 times 10 to the minus 11 meters cubed over kilograms seconds squared. Okay, so now what I want you to do is write the dimensions for these numbers. What do we do when we look at dimensions? We don't worry about the actual numbers. We only worry about units. I want you to write them down, and I will promise not to look at anything, and then I will write them, and then we will check. Remember, dimensions can only be L, M, and T. So don't look up. I'm going to start writing.
No,
not yet? Okay, I'll wait.
Compare notes to just
Anyway, okay, I'm going to, ready?
I'm ready when you are.
Ready? Okay, I'm going to start writing. Tell me when I mess up. M and T, right?
Yes, ma'am.
Did I do that right? Meters
Hot dog.
per second? Okay, so did we get it all right?
Yeah.
Okay, so that means, here's the trick. No matter which one you're doing, Planck length, Planck time, or Planck mass, the right-hand side will always be the same. So I will write proportionality. This is proportional to always C alpha, G beta, and H gamma. Now this part of the box needs to be filled. This depends on what you want to do. So in our case, what do we want? Good. So fill it with LP. Now we're going to write dimensions for every single one. What will be the dimension on the left-hand side? What will be the dimensions on the right-hand side? You see it? Yep, just write all of them. And for G, it'll just be, so G will be L to the 3 beta, M to the minus beta, and T to the minus 2 beta. And then my H will be M gamma, L 2 gamma, and T minus gamma. Okay, so now that we have that solved, let's put them all together. All the L's together, all the T's together, and all the M's together. And I'm doing them too. Don't look up. Okay? I'm doing them with you. Just don't look up. We should have all the powers of L together and T together and M together. And look up and make sure after you're done that I did not mess anything up.
You have the same thing.
Yeah? Okay, excellent. So now, what do we have to do? Look at the left side. L is to the power 1. Can I multiply by 1 and multiply by 1? Any rule that says I can't do that? What is anything to the power 0? 1. So instead of this 1, can I write here M to the power 0? Over here, can I write T to the power 0? So I'm just adding those two things in, right? Change this color to red. So I just did that. Am I allowed to do that?
Yes.
Mathematically? Yes? Okay, excellent. So now start equating the powers. What that means is, mathematically, I am allowed to write this.
Will be used against you.
I know. When they
Yeah,
get
y'all will have an easier time.
Meanwhile, there'll be people.
See what the matrix is going to become in.
I didn't use a matrix. You don't
No,
have to.
you don't have to use a
No.
matrix.
Thank God.
It's just like
Make your life
basic
easier.
algebra.
Don't use a matrix.
Just start with the easiest equation and then go from there.
Let's go.
So 1, 2, 3. Let's start with number 1. Do you guys want to do this or on your own, or do you want me to do it?
I'll follow along.
And then I can take these two equations and I can solve them. This goes away. What am I left with? 1 equals plus beta plus gamma. So that means I
I
can plug this one in here.
just plugged it in separately.
1
Sorry.
equals beta plus beta, right?
Yes, that's how it works.
And then that one is 1/2 equals beta.
Yes.
That's what you got?
Yes.
Cool. And then that means that since beta equals gamma, so gamma should also be 1/2, right?
Yes.
And since now we have beta and gamma, I can plug it into equation 2, right? Pick an equation to plug it into. 0 equals minus alpha minus 2/2 minus 1/2. So it's a half minus a half, that will give us 3 halves.
Yes.
And so then we will get alpha equals minus 3 halves.
Yes.
Okay, follow along.
Mm.
So in the end, you should get beta equals a half, gamma equals a half, and alpha equals 3 halves minus. Once we have alpha, beta, gamma, guess what we're gonna do?
Plug it back in.
Oh, yeah.
Which one?
The first
All of
one.
The first one at the top.
Yay.
And now that will answer Zain's question.
Okay. Why do we do it?
Which question?
The one you said, why are we doing this?
Yeah,
That one. Yeah.
That one. So plug them back all in.
You get the equation.
Yeah, C is to the
Yeah.
negative 3 halves. G is to the negative half. And H is to the negative half. Yes?
Yeah.
Okay. What is anything to the power a half? Can I write this as G square root H square root divided by C to the power cubed square root?
Heck yeah.
Yes.
Yay.
If
We're
you
done now.
plug numbers in, you will discover that your answer will be very, very close to yes.
Does that mean you just switch where the one is?
That's exactly right. So in order to get Planck's mass, guess what you have to do?
You just put it where the 0 is at the top,
Can I do this thicker?
probably.
In this box, change LP to MP to calculate mass. Change this to TP in order to get time. And the only difference we'll make is whether this is 1 or this is 1 or this is 1. Everything else will remain exactly the same.
Yay.
That's the magic of dimension analysis.
That's awesome.
However, what you will find is that the algebra will change later, right? Because it will depend on whether this is 1 or this is 1 or this is 1.
Yeah.
Everything else will be 0.
Yay.
It pops up like magic. So that brings us to the end of this. So, okay, appreciate what you guys have just done.
This is
It's
yeah, this is
literally-
awesome.
It's awesome.
Yeah, seriously. All right.
That's
Heck
awesome.
yeah.